Okay, so for 10.5, the rest of this, we're moving on to the infinite geometric series. So what this is saying is it's telling us that it's going up to an infinite, but it wants the sum for up to the infinite term, and this just defines a geometric sequence. If you want to read in your book, it goes through and explains, but eventually they are going to get to the infinite sum equaling just the first term divided by 1 minus the rate. So for this, you need to pay attention to these two things right here, okay? You need to pay attention to the word diverges and the word diverges down here. So if the absolute value of the rate is greater than or equal to 1, it's going to diverge as in increases. This means that there's no finite sum. So for those problems, you can literally just write no sum or no finite sum, whichever one you want to for that. If it converges, it's going to end up giving you an answer, okay? So I'm going to move down to these questions. So for example E, we have find the sum of the infinite geometric series that's defined by the following sequence. So for this, we need to write down our first term, and we need to write down the rate, which is the second term divided by the first term, so 1/3. So our rate is the absolute value of 1/3 is less than 1, which means it's going to converge. So we have to use the formula to find what it's going to converge on. So we have S sub n equals 3 divided by 1 minus 1/3. S sub n equals 3. 1 minus 1/3 is 2/3. I can keep the first, change the symbol from division to multiplication, and flip the second, and I end up with S sub n equals 3 times 3 over 2, which is going to give us 9 over 2 as our answer for that. Okay, pretty quick compared to the stuff we were doing before. Example F says, find the sum of the geometric series defined by the sequence 5, 10, 20, 40, 80. Okay, so our first term is 5, and our rate is 10 divided by 5, which equals 2. The absolute value of 2 is greater than or equal to 1, so it's going to converge or diverge. It diverges, which means there is no finite sum. And that is actually your answer. You are done at that point, okay? I'm going to move over into example G. So example G says, find the sum of the geometric series that's defined by the sequence 4, 3, 9/4, 27 over 16, 81 over 64. So we're gonna look at our first term, which is 4. And we're gonna look at our rate, which is our second term, divided by our first term. And 3 over 4, the absolute value of that, is less than or equal to, or less than 1, because it is a fraction. So we're gonna have to use our formula. We've got kids screaming in the background. So this is going to be 4 divided by 4 over 4 minus 3 over 4 is 1 over 4. And then we can continue this by saying, again, keep the first term, change the symbol to multiplication, flip the fraction, which gives us 16 as the number that it is going to converge on. So since it's going to converge because it is a fraction for the rate, we're going to end up with 16 as our final answer.